Okay, we'll keep watching. Just for the viewers who are watching along with us, it'll probably be a bit of a challenge for us to lock onto it, but it looks like we see the craft there, and that's what Orion, or the test version of Orion, is inside of right now, and will be pushed out the back of for the test.
And I'll just give you a call as I can watch it if you'd like me to, Brandy. We're out of the airplane. A good initial extraction. In the test vehicle, the PTV is away from its sled. Coming down under the programmers. Looks good so far. We're still falling under the programmers. Just cut the programmers away. We're going to let it free fall for 10 seconds and accelerate.
And Stu, tell us again what that free fall does.
Free fall allows gravity to do its job and allow us to accelerate to our test condition. And the faster we let the vehicle fall, the more it is able to accelerate and give us a more representative test condition. So the closer, more closely matches the flight entry that we'll see during EFT1. And we're under drogues. So we've had a good forward bay cover separation. I'm just tracking the PTV, the test vehicle, at the moment on my binoculars. And we just cut away.
3 pilots deployed, 3 main deployed.
3 pilots out. The mains have started inflating. Just heard the pop from the chute inflating. I don't know if Brad has this on camera. 1 chute's inflated, the other 2 are not yet. This was one of our other planned test objectives, which was simulating. Okay, good. Yeah, and so that's simulating what happens if one of the reefing stages opens prematurely for some reason, and if it skips a stage. Because we designed this assuming that the parachutes share the reefing. Yeah, thank you. Yeah, reefing is a way to open the parachute in gently or softly. If you went full open, think of going extremely fast and hitting your brakes really, really hard. You put a lot of energy into things, right? It's dumps a lot of energy both into the structure of the vehicle and in the parachute. And so we have ropes that constrain the diameter of the parachute, and they have pyrotechnic timers that allow them to open up, say, 10% initially, and then I think, I don't know if Molly remembers the exact number, I think it's 10 and then 20%, and then we go full open. And that allows you to open up the chutes gracefully and kind of more slowly spread the energy into the parachutes and into the vehicle. Again, by reefing, you kind of control and manage that energy, and it allows you to not design and carry quite as much mass in the system.
Well, it looks great from here. We're seeing a really good view. Thanks for getting that for us. I guess while we watch it make its way down to the ground, we can take a few more questions. We actually have one for Molly from Nick Lopez. Says, what kind of temperatures do you predict you'll see during entry based on your wind tunnel testing?
Well, we don't get up to the actual temperatures that we're going to see in flight in the wind tunnel test. But for EFT1, we're predicting a peak surface temperature of around 4,000 degrees Fahrenheit. That's 2 times the temperature of molten lava. And that's just for Orion's first flight test, which isn't going to completely stress the system as far as Orion will once we actually fly Orion's real missions out to the moon and beyond. For those missions, we're going to be seeing peak surface temperatures upwards of 5,000 to 5,200 degrees Fahrenheit.
So that brings up another question that we've gotten from Philip online, and he asked, how can the module be adapted for future missions? Does it need to change before the next flights?
Certain parts of the vehicle have already changed between the first flight test and what we're going to be flying on future missions. But the material that surrounds the vehicle, we call it its thermal protection system, and that's what protects it from those high temperatures on the surface. It's an insulative layer that's also designed to burn away and take that energy away from the surface. That thickness of that material can change depending on your mission, and then also we'll learn a lot from the Exploration Flight Test 1 or Orion's first flight test, and that will feed into the design for the future flight tests. We might need to adjust certain thicknesses or adjust what material is used for certain regions, and those are the design changes that we'll go into between the first flight test and the second flight test.
Great, and it looks like we've got the vehicle touched down now on the desert in Yuma. Everything looking good, Stu?
Yes, I don't know if you see so I'm assuming Brad's got the shot. You see 2 of the 3 parachutes, and they're just starting to deflate. And like I said, the ground winds here today are in the 7, 8, 9 knot range, and these parachutes are very effective. And so one of the things that we have to do is make sure we get them deflated, and the last 2 are hanging on for a little bit. But the vehicle's down. It was a good test. And I saw the forward bay cover, we obviously had a good clean separation. It's down on the ground already. Yeah,